Guys, and welcome back to Let's Grow Together. In today's video, we are going to cover a few topics from cryptography. Let us start with Euler Totient function. So here let us start with the definition. It is defined as the number of positive integers less than n and relatively prime to n, and it is denoted by pi of n. And I think for explanation it will be much great when we explain through examples. So for now this is the definition and I will explain in detail about this definition in the upcoming problems. So here the case one is if n is any prime number, then how we are going to find the Euler Totient function? It is simply n minus 1. Okay. So next, if n is a product of prime numbers, product of two prime numbers, then we are going to write it as Euler Totient function of n is equal to Euler Totient function of p into q. So then we are going to split Euler Totient function of P into Euler Totient function of Q. And here we know that P and Q are two prime numbers. So what will be the Euler Totient function of prime numbers? P minus 1 and into Q minus 1. That will be the Euler Totient function of n if n can be written in terms of product of two prime numbers. So the case 3 is if n is not a prime number but it can be written as prime number power I, then this will be the formula. So what's the formula? P of I minus P of I minus 1. And the case 4 is if the question falls uh, among any two cases listed above, then we are going to use this formula. So what is the Euler Totient function of this case? Is equal to n into product of 1 minus p terms. So this is about Euler Totient function. So now let's move on with some problems. So the question is to find the Euler Totient function of 97, 10, 343 and 63. So Euler Totient function of 97, and as we know that 97 is a prime number, so the Euler Totient function of a prime number will be the n minus 1. So 97 minus 1, which is 96. I hope I'm clear up to here. So further, next we are going to find the Euler Totient function of 10. So 10 can be written as a product of prime numbers 2 into 5, and this falls under case 2. So how we are going to do Euler Totient function of 2 into Euler Totient function of 5. So Euler Totient function of 2, it will be 2 minus 1, and for 5 it is 5 minus 1. So 1 into 4, 4. So here now let us see what does the definition exactly mean. So count of positive integers that are less than n and are relatively prime to n. So look here. So Euler Totient function of 10 is equal to 4. This is the value which we get. So now what we are going to do, we are going to find GCD of 1, comma 10, 2, comma 10, 3, comma 10, 4, comma 10, 5, comma 10, 6, comma 10, 7, comma 10, 8, comma 10, and 9, comma 10. When you find these GCD values, here GCD of 1, comma 10 is 1, and 3 comma 10 is 1, 7 comma 10 is 1, 9 comma 10 is 1. So what is the total count? 4. This is what our Euler Totient function states. Okay. So there will be n number of values which are relatively prime. What does this relatively prime mean? When you take GCD, you should get the value as 1. So next we are going to find the Euler Totient function of 343, and 343 can be written as 7 cube. When you write it like this, then the formula is so p power I minus p power I minus 1. So 7 cube minus 7 power 3 minus 1, which is 343 minus 7 square, which is 294, and this is case 3. So next we are going to find the Euler Totient function of 63. So 63 can be written as 9 into 7, and 9 can be written as 3 square. So if you see here, we have combined two different cases here. So if you see here, this will be falling under case 3, and if you take Euler Totient function of 7, it will fall under case 1. So here that it is a combination of two cases. So what is the formula n? What is the n value? 63 into product. So 3, 1 minus 1 by 3 into 1 minus 1 by 7. If you do this, you will get. Otherwise, this is an alternate method. So you can write it as 9 into 7 and Euler Totient function of 3 square into Euler Totient function of 7. And here again it falls under case 3 and it is a case 1. So we know the formulas, we are simply going to apply them and we are going to multiply them and we are going to get the result. So next we are going to find the Euler Totient function of 72. So it is similar to the previous question which we have solved. If you have any doubts regarding this topic, don't forget to drop a comment and I'll definitely give you reply. So next, let's move with the RSA algorithm. So RSA algorithm is an asymmetric cryptographic algorithm. So what does this asymmetric mean? Here the keys will be different for encryption and decryption. So let us see the algorithm first. So let us consider the user B as the receiver. So first we have to, for the step 1, we are going to select P and Q such that both are prime and they should be not equal to each other. And in step 2, we are going to calculate the value of n, which is p into q. Once you find out that, next we will move on with step 3. What does this step 3 says? We have to find the Euler Totient function of n. So what will it be? Euler Totient function of n is equal to Euler Totient function of p into Euler Totient function of q. And this falls under case 3, right? Because we are able to write the n in the form of product of two prime numbers. So what will be the value? P minus 1 into q minus 1. And then in the step 4, we are going to select an integers e such that the Euler Totient function, GCD of Euler Totient function and e should be equal to 1. So that is a condition, and then 1 less than e less than Euler Totient function of n. Once we are done with that, then we will proceed with step 5. In step 5, we are going to find the value of d, where d is given by d is congruent to A inverse mod Euler Totient function of n, and the public key is equal to E comma n and private key is equal to d comma n. After that, we are going to move with encryption by user sender with user B public key. So here what we are going to do, we are going to find the encrypted text. So what will be the formula for encrypted text? C is equal to m power e mod n, where e is the public key and d is the private key. Okay, so C equal to m power e mod n. Now for decryption, what will be the formula? M equal to C power d mod n. Now let us see the formula. Perform encryption and decryption for the following parameters using RSA algorithm. And in the given question, we have P, Q, E, and M values. So the P is 3 and Q is 11, E equal to 7 and 11 is 5. Before proceeding with the problem, we have to check whether the P and Q are prime numbers and they should be not equal to each other. Once we have checked, then we will proceed with the next step. So what we have to do, we have to find the value of n is equal to P into Q, which is 33. Next, we have to find the Euler Totient function of n. So Euler Totient function of 33. So 33 can be written as 3 into 11 and which falls under case 3. So 3 minus 1 into 11 minus 1, 2 into 10, it's 20. That is what here I have written. So next, already we have chosen the e value as 7. Now let's check whether the GCD of 20 comma 7 is 1 or not. So since there are no factors which are common for both 20 and 7, the GCD of 20 comma 7 will be 1. And if you see, the e value is greater than 1 but less than 20. So the condition satisfied. Now we can proceed with further steps. So d is equal to e inverse mod Euler Totient function of n. What is the value of e? 7 inverse mod 20. So how we are going to find the inverse mod? So here you can see. So 7 into x mod 20 is equal to 1. So what will be the x value such that when you multiply it with 7 and when you do mod with a 20, you are going to get the value as 1. So here in our case the x value will be 3. You have to substitute x values from 1. So if you substitute 1, the 7 mod 20 will be 7. It is not equal to 1. So next x equal to 2. 14 mod 20 which is equal to 14 and it is not equal to 1. So when you substitute 3, 21 mod 20 will be the 1. So we are going to take the val. Therefore, the value of d is 3 and the value of public key will be the e comma n, right? So what is the value? 7 comma 33, and for the private key it is d comma n. D value is 3 and comma 33. So now encryption, we are going to find the value of C. First we have to check whether the M is less than N or not. Once the condition satisfies, then we have to find the value of C, which is encryption. So C equal to 5 power 7 mod 33. 5 power 7 is large and we can't find 5 power 7 mod 33 directly in the calculator. So what we are going to do, we are going to split the powers, 5 square into 5 square into 5 square into 5 mod 33. So we know 5 square is 25 and we have to find 25 5 mod 33. Once you find that, you have to multiply them and again you have to find with mod 23, the resulting value mod 20 33. Then you will be getting the C value as 14. Then you have to decrypt. For decryption, what is the formula? M is equal to C power D mod 33. So what is the value of C? 14 power D value is 3 and mod 33. Next, let's move with the Chinese remainder theorem. So in Chinese remainder theorem, this is the problem. Solve the following linear congruency using Chinese remainder theorem, and they have given us three equations. It is not mandatory that they have to give three statements in the equation. It may vary. So first we have to write it in the form of EI mod MI. So what here I'm going to do, I'm going to assign the values, these side values with A and this side values with M, E1, A2, A3, M1, M2, M3. After that, what is my final goal is to find summation of EI mod M. So this is my ultimate goal. Then mi values are relatively prime. So we have to check whether the mi values are relatively prime. GCD of 3 comma 5 is 1, GCD of 3 comma 7 is 1, GCD of 5 comma 7 is also 1. Only then we can proceed with this problem. So next we have to find the value of capital M, M1 into M2 into M3. So the value of M1 is 3, M2 is 5 and M3 is 7 from the given question. So we're going to multiply it and we're going to get the capital M value as 105. Then we don't know the value of Ci. So for Ci, the formula is Mi into Mi inverse mod Mi. So here again we don't know the value of Mi. So to find Mi value, we are going to do it as mi equal to m by capital M by small mi. So m1 is equal to m value is 105 and m1 is 3. The value is 35. Similarly, you have to find the values for M2 and M3. After figuring out these values, then we have to find the values of C1, C2 and C3. So for C1, the formula is M1 into M1 inverse mod M1. So the value of M1 is 35 into 35 inverse mod 3. And as I told in the previous question how to find the value of inverse, 35 inverse mod 3 is equal to 35 into x mod 3 should be equal to 1. So you have to check and find the value of x by substituting the values from 1. So it is trial and error method. So once you figure it out, here for this question the value of x will be 2, and similarly you have to find the value of C2 as well as C3. Once you find out these, then we have to find the x value, which is equal to summation AICI mod M. So this is equal to A1 C1 plus A2 C2 plus A3 C3 mod capital M. So capital M is 105 and then E1 value is 2, C1 value is 70. You have to multiply and add, and then you have to find out the mod 105, then you will get the value of x. So how to check whether our answer is correct or not? So here you go. So these were the given equations. What we are going to do, we are going to replace x mod 3, x mod 5, x mod 7 is equal to this side value. So 241. So we got the x value as 29. We have substituted it and we are going to find 29 mod 3 2, 29 mod 5 4, 29 mod 7 is 1. So this is the Chinese remainder theorem. So next we will move with the Diffie-Hellman's algorithm. So it is also a key exchange algorithm which is published in 1976. And here the Diffie-Hellman's key exchange is used to securely transmit the key between the sender and receiver. So first, let Q be a prime number and alpha be the prime root of Q. So the key generation for user A Select private key XE such that XE should be less than Q. Calculate public key YE with the given formula. YE equal to alpha power XE mod Q. So Q is the prime number and alpha is the primitive root of Q. So this is the key point which you have to remember. Then next, for user B, select private XP where XP less than Q and calculate the public key YB equal to alpha power XB mod Q. So how to calculate the secret key? K equal to YB power XA mod Q. So calculation of secret key by user B, K equal to YA power XB mod Q, and you can use any of the formula when you're finding the secret key. So to see both are equal, here is the proof. YB power XA mod Q. YB can be written as alpha power XB mod Q power XA as it is in the question, as it is in this formula. Then mod Q. After that, what we are going to do, since mod q is common, we are going to write it like this: alpha power xb whole power xa mod q. Then I can write it as like this, right? So alpha power xb into xa mod q. Then alpha power xa mod q, the value is ya power xb mod q is the value. So we can either use this key secret key calculation or this one. Okay, so now we'll proceed with the problem. Given prime number q equal to 11 and alpha equal to 2, user a public key is 9 and user b public key is 3. Show that 2 is a primitive root of 11. So how we are going to find the primitive roots? So now let us see that. So if the value of n be the 11, you have to find the Euler Totient function of 11. It will be 10 since 11 is prime. It falls under case 1 and minus 1, so 10. So 10, you have to write 10 in the form of prime factors. So those will be 2 comma 5 and then 2 power pi of n by 2 mod 11 should not be equal to 1. Similarly, 2 power pi of n by 5 mod 11 should not be equal to 1. Only then we can say that the that they are primitive root. Okay, 2 is the primitive root of 11. Mm. And these 2 and 5 are the prime factors of 10. If there is one more prime factor, if you consider, for example, 7, then you have to find the value for 2 power Euler Totient function of n by 7, and these values should also not equal to 1. Only then we can say that 2 is the primitive root of 11. So same logic here also we are going to apply it. Before going to apply the same logic, we have to check whether the q is prime or not. Once we confirm that the q is prime, then we will proceed with this problem. So here if you see, simply we are finding the primitive root, whether 2 is primitive root of 11 or not. Even that is the given question, right? So yes, so we have to find that 2 is a primitive root of 11. So the same procedure which I have said earlier is what we are going to follow over here. Since the values are not equal to 1, we can see that the 2 is primitive root of 11. And that's it for this problem. And next problem, given prime number is 71 and g is equal to 7 and xa equal to 5 and xp equal to 12. What does this xa and xb represents? The private keys of e and b. So here if you see, the representation has varied. Earlier we have used alpha, but now we are using g. So what does this mean? The representations may vary, but you have to understand the concept. So same, first you have to check whether the given number is prime or not. Once you confirmed that the given number is prime, then what we are going to do? We are going to find whether the value of alpha is primitive root of the prime number or not. For that, what was the method we have discussed? So Euler Totient function of 71 is equal to 70, because 71 is prime, so n minus 1 70, and 70 can be written as 2 into 5 into 7, so those are these prime factors. And then what we have to do, we have to find whether the Here the given value is 7, right? So 7 power. So Euler Totient function of n divided by 2 divided by 5 divided by 7, and then we have to find mod 71. Once you find out the values of all these three, they should be not equal to 1. Only then the 7 will be the primitive root of 71. After this, we are going to proceed with the problem. So now what we are going to do, we are going to find the public key of A is equal to, the formula is alpha power xa mod q. So what is the value of alpha given in the question? It's 7. What is the value of private key for A? It's 5 mod 71. We have to determine this value and it will be the 51. So similarly, you have to find the public key for the user B also. So the further the formula will be alpha power xb mod q. So once you find out this value, we will be getting the public key of B user B as well. Then what you have to do, you have to find the value of or calculate the secret key used by user A and user B. As I told, we can use any one formula. So k is equal to yb power xa mod q. So what's the value of yb? It's 4 and xa is 5. 4 power 5 mod 71 is 30. And for verification, if you want to verify whether your answer is right or not, go with the another formula also. So for both the formulas, you have to get the same value. That's all for today's video. If you find this video helpful, don't forget to like, share and subscribe to our channel. Let's grow together. Thank you everyone. If you have any doubts, don't forget to comment down below. I will definitely reply you and make sure that your doubt is cleared.